Welcome back. We are continuing this lesson on discriminant, the discriminant. In general, for any given quadratic equation in the form in the form a squared plus bx, or let me put it this way. In the form y equals to ax squared plus bx plus c. Then b squared minus 4ac is called the discriminant. Good. The value of the discriminant shows how many roots f of s has. The value of the discriminant shows the number of roots f of x has. Good. Then let's take the first one. If the discriminant says that b squared is greater or equal to 4ac, then this indicates that the given quadratic equation has two real and distinct or different roots. When you observe that the discriminant is b squared is greater or equal to 4ac, then it indicates that the given quadratic equation that may be in the form of this, possibly or with all reasonable degree of certainty, has two real and distinct roots. Good. What does that mean? Okay, take your time, copy it, we'll take the space and then define everything again. Take your time to copy it. We'll come back again. Good. The following will be the three basic discriminants that we are going to describe. About the first one. When the discriminant says that b squared is greater or equals to 4ac, then it indicates that the given quadratic equation, which is of the form y is equals to a squared plus bs plus c, has two equal and different roots. Sometimes we say that two equal and distinct roots. This means that if the discriminant is like this, then the given quadratic equation has then the given quadratic equation has two real and distinct or different distinct roots. That's the first one. That means, what's the meaning of that? That indicates that assuming this is the graph of the quadratic function in the form of a squared plus bs plus c, assuming this is the curve or the graph of it, then you can see that let's assume that this is the graph. Then you can see that this one is equals to s2 and this one is equals to s1. These are the two distinct roots. Oh, but in that case, if you draw this graph, then in that case, this specific graph is valid when a is greater than 0. But there is also another two distinct roots that could be. In this case, when a is greater than 0, then it has y minimum. But what about when it has y maximum? Then the two distinct roots will have a graph that looks like this one. S2 x1. This is x and this is y axis. Good. And in that case, this will be a is less than 0. What is that? Remember that we are talking about a quadratic equation of the form y equals to a squared plus bx plus c. Good. Okay, that's for the first one. And the second one, let me see. The second one, it says that b squared is equal to 4ac. What does that mean? I mean, I think before I can continue, let me do something here. Oh, don't worry. I think we'll come to that one. No problem. B squared is equals to 4ac. What does that mean? This indicates that the given quadratic equation, which is in the form y equals to a squared plus bs plus c, I mean that the solution of that quadratic equation, it has one repeated root. What does that mean? Let's write something down. This indicates that the given quadratic equation has one repeated one root that is repeated. Don't worry. I will explain everything, into details to you. Just have the concept of the whole thing. The first one, when you see that, you pick up the coefficient of x and you square it, and it is greater or equal to, or sometimes we can say that when the b squared is greater, let us do it is greater. It will be simpler that way. When the b squared is greater than 4ac, then the given quadratic equation has two different roots, but they are real. When you square the coefficient of x, which is b, when you square it and it is exactly equal to 4ac, then it indicates the given quadratic equation that you are considering has one repeated root, one repeated roots. Good. Then the third one that says that b squared is less than 4ac indicates that in the given quadratic equation, there is no real value of x of which the curve crosses the x-axis Good. So these are the basic things that we are considering on the discriminant. Now we are going to examine into details these concepts. B squared is greater than 4ac being the first one. We have said that when that happens, it indicates that there are two real and distinct roots. The second one, when you see that the b squared is exactly equals to 4ac, it indicates that the given quadratic equation has one repeated root. And the third one, which says that b squared in fact is less than 4ac, which indicates that concerning the given quadratic equation that you've been given, there is no value of s of which the curve will cross the x-axis. Now, take your time to cooperate, and we'll get into the exact detail of the graphs. Take your time, copy it. Okay, let's continue. The first one, we say that b squared is greater than 4ac. Now, this is how the graph will look like. For instance, this is I call it first estimate. Not exactly, but this is how it should look like under this condition. For instance, if you are given a quadratic equation, for instance, for y equals to ax squared plus bx plus c. This is how the graph should look like. The first one, at this time, let us assume condition A, or let me call it condition 1. When condition, how should I call it, condition I, the case when A is greater than 0, then the graph will look like something like good. And the C, this is the graph Y, and the C is this one. And S1, which is negative B over 2A plus B squared minus 4AC in a root all over 2A. And this one is the S1, oh no, let's make it neat. S1 is equal to negative B over 2A minus B squared minus 4AC in the root, 4AC in the root all over 2A. That's this one. Or for a neat way, why don't we take time, to do everything on the board for simplicity's sake? Then, to do that, this graph should go away. Then systematically, we describe each of the discriminants precisely on the board. In that case, we have the whole board for one graph at a time. For this one, it becomes this one is equals to, remember, because A is greater than 0, the curve will have Y minimum. And this is Y-axis, and this is X-axis, and this is the Y-axis intercept, which is C. And this is X1, which is negative B over 2A plus B squared minus 4AC in the root over 2A. And this one, this is the origin, and this one is the S1 equals to negative B over 2A minus B squared minus 4AC in the root over 2A. But remember, there's a symmetry over there, and this specific point is called this the equation of the symmetry. This point, which is X, which is equals to negative B over 2A. Very good. Yeah. So, under this condition, the B squared greater than 4AC says that the B squared greater than 4AC says that the curve or the curve or the solution of the quadratic equation, has two real roots, real and distinct x1 and s2. So this is the definition. When b squared is greater than 4ac, then the solution of the quadratic equation, which is this one, has two real and distinct roots that are x1 and x2. That is, when a is greater than 0, then you have this curve. But at the same time, under b squared greater than 4ac, when a is less than 0, which I will say that it is this one, condition 2, a is less than 0, then you can see that the same graph, at this time, it will have y maximum. So you can see that the graph will be like where this one is equals to s2 equals negative b over 2a minus b squared minus 4ac over 2a. And this one is x1. x1 the same like this, negative b over 2a, but because there's no space, I don't think I can write it there. So you can figure it out. And you can see that there's symmetry over here as well. This point is s equals to negative b over 2a. This is the symmetry. So you can see the two real roots. They are two real roots, but they are different. This is it. It has two real but different roots, being xy and x2. This is the y-axis intercept. This graph is when a is less than 0, meaning the coefficient of s squared is negative. Under that condition, the graph will have y maximum. Good. Take your time to copy it, and then we'll move it from there. Or, yeah, take your time to copy it, and we'll move it from there. Now, the second one has equation. The second one is b squared is equal to 4ac. This means the quadratic equation has a one repeated root, has a one repeated root. What does that mean? Assuming case 1, a is greater than 0. This is how the curve will look like. This is the C, y-axis intercept, and this is the root. Here, x1 is equal to s2. The two, these two that I've written there, I've drawn there, tells you that the curve touches the x-axis 2 times. It touches the x-axis 2 times means it has a double root, or we can say that one repeated root. Under this condition, x equals to x1 equals to s2. This is the case. Here, y minimum is equals to 0. Here, y minimum, you can see that the y minimum, the quadratic equation, because a is greater than 0, it has a minimum turning point. But the minimum turning point occurs on the x-axis, where y is equals to 0. Here, y minimum is equals to 0. Y minimum equal to 0. Good. And then another case, which is the alternative one. This is x-axis. Case 2. When a is less than 0, the same curve will have a maximum turning point. So it will be like this. x1 equal to s2. We say that one repeated root 0 c y x origin. So when you have a given quadratic equation, y equals to a squared plus bs plus c, and you pick up the coefficient of x, which is b, and you square it, and you pick up the coefficient of x, which is s squared, which is a, and the constant, and you relate it to this equation. When the left-hand side is equal to the right-hand side, it indicates that the graph will touch the x-axis twice at the same point. That's why we say that it has one repeated root, and in some cases we can say that it has a double root. Okay, that's the point 2. Then take your time to copy it, and we'll pick it up from there. The next one will be the third one. For a given quadratic equation, when b squared is less than 4ac, then it implies no real solution. In that case, case 1, where a is greater than 0, the curve will look like it will not cross the x-axis, meaning there is no value of x for which the equation has a solution. There is no value of x. This is how the curve will look like. It will not cross the x-axis. So this is x-axis, y-axis, and this is the intercept. So it doesn't cross the x-axis. Okay, the other case is when case 2, when a is less than 0. Case 2. The curve will look like it comes, but it will never reach the x-axis. This is y-axis intercept, y-axis. This is x-axis, this is origin, this is origin. Good. You can see that it doesn't cross the x-axis. Therefore, there is no real value of x for which the curve crosses the x-axis. This is when the case b squared is less than 4ac. Good. And this was the last point. Take your time to copy it, and we'll pick it up from there again. Now, in summary, this is how it is. The first one, b squared is greater than 4ac. It is, the curve will look like, this is y, and this is x. The curve will look like this. x1, x2. For the case a is greater than 0. Okay, which indicates for this equation, because there are two real solutions, but they are different. x1 is not the same as s2. Then, for the case when a is less than 0, under the same condition, it will be y x2. I always call this one x1, x2, and this is x1, x, and this is the origin, The second case, when b squared is equal to 4ac, case 1, a is greater than 0. In that case, you can see that the curve will touch the x-axis twice, meaning one repeated route, y-axis, x-axis, and this is equal to, this is origin, and here s1 is equal to s2, identical routes. And for the case, this one is for the case when a is less than 0, and we came to this point, and this time y x c, y-axis intercept c, and this one touches twice, x1 equal to s2, under the condition a is less than 0. And the third one, which is of the form b squared is less than 4ac, whose graph, under the condition that under the condition that a is greater than 0. So this will not touch the curve will not touch the x-axis when a I think you may not see it, so I have to push it up a bit. under the condition that A is less than 0. So you can see all the three cases. Yeah, take your time to copy it, and then we'll take real life mathematical examples. Take your time, copy it. Yes, let's take this example, which says that find the values of k for which f of x equal to s squared plus kx plus 9 has equal roots. Has equal roots. Good. Find the values of k for which f of x equal s squared plus ks plus 9 has equal roots. Solution. We are given the function over there as f of x equal to s squared plus kx plus 9. The first thing that we have to do is to write the general quadratic equation of the form ax squared plus bx plus c. Let's call this one equation alpha. Comparing coefficients and constant, we can see that if you compare coefficients of s squared, you can see that the coefficient of s squared, a is equal to 1. A is equal to 1. Because here, you can see there's 1 in front of the s squared, but we don't write it. So you can, if you are comparing the coefficient of s squared, you can see that a is equal to 1. Comparing the coefficient of x, you can see that b is equal to k. Comparing constants, you can see that c equal 9. Now, watch closely to the grammar. The grammar says that find the value of k for which the given quadratic equation has equal roots. What's the meaning of equal roots? The equal root is this one. I would say that a quadratic equation has equal roots if and only if a quadratic equation has a quadratic equation of the form ax squared plus bx plus c has equal roots. When b squared equals to 4ac. Now, what is b squared? B squared is equals to, what is b? B is a k, so k squared equal 4. What is a? A is 1. What is c? 9, which indicates that k squared equals to 4 times 1 times 9 is 36, which implies is k equal plus or minus root 36. Therefore, k equal plus or minus 6. So when it says then find the values of k and find the values of k for which the quadratic equation s squared plus ks plus 9 has equal root. Has equal root means the discriminant, the most feasible discriminant to be used is the b squared equal to 4ac. And with that one, you can find the two values of k. This is just simple one. Take your time to copy, and then we'll take the next question. Okay, the next one, it says that find the range of values of k for which s squared plus 4x plus k equal to 0 has two distinct and real roots. Who tells you that? Solution. S squared, this equation, plus 4x plus k identical to as squared plus bs plus c equal to 0. Compare the coefficients and the constant. We can see that a equal 1 whilst b equal 4 and c equal k. But for two distinct and real roots, the most feasible discriminant is defined by b squared is greater than 4ac. Now, what is b? What is b? b equal to 4, therefore 4 squared greater than 4. What is a? A equal 1. What is c? C equal k, which indicate that 4 squared is greater than 4k, which is no different from 16 is greater than 4k. Or we can say that 4k is less than 16. Dividing both sides by 4, we will have k is less than 16 over 4, which indicates that k is less than 4. Therefore, this is the value of k. Yeah, k is less than 4. So the range of the values of k is all values of k that are less than 4. This is it. Take your time to copy, and we'll take another example. Let's take another example. The example says that find the values of k for which have we considered this question? Oh my I don't know. Let's see. I think we have considered it. Let me see. Anyway, let's see. For which s squared plus 6x plus k equal to 0 has two real solution. Good. Solution. The given quadratic equation is s squared plus 6x plus k identical to as squared plus bx plus c 0. Comparing coefficients of s squared, the coefficients of of x and the constant, we can see that a equal to 1, b equal to 6, and c equal to k. Good. The curve, the suggesting discriminant or the condition is saying that has two real solution. Has two real solution is this one. B squared is greater than 4ac, which we said earlier that's two real solution, but they should be distinct, different. So this is the most feasible discriminant that we can use for such question. So in this case, we have here b is equal 6 squared greater than 4, a equal 1, c equal k. So we have 36 greater than a equal 1. A equal 1. 36 greater than 4k, which implies is 4k is less than 36, which implies is k is less than 9. It looks to me that we saw this question earlier on. Then that's it. Yes, this is also another question to be considered. At this time, it says that find the value of t for which 2x squared minus 3x plus t equal to 0 has exactly one root. It's not a big deal. Find the value of t for which 2x squared minus 3x plus t equals 0. Solution. Has exactly one root. The most feasible discriminant is this one. B squared equal to 4ac. Has exactly, this discriminant indicates that the quadratic equation, the given quadratic equation, has exactly one equal root. Good. So you pick up the quadratic equation, which says that 2x squared minus 3x plus t equals to 0, being compared to the general quadratic equation ax squared plus bx plus c equals 0. Comparatively, comparing the coefficients of s squared, the coefficients of b, the coefficients of c, and the coefficient and the constant, we can see that here the coefficient of s squared, this one and this one, indicates that a equal to 2. Coefficient of x b equal -3, and the constants are c equal t. Then we use the discriminant. The discriminant, the b is -3 square minus, so equal 4. A is 2 times 2. C is t. Good. So we have 9 equal 8 t. Good. Which indicates that t equal 9/8. That's the answer. So simple. Take your time, copy it, and we'll come back again. Yeah. I come back. This is a past question. It carries, I think, 2 marks. It says that find the range of values of k for which 3x squared minus 4x plus k equals 0 has no real solution. Solution. The given quadratic equation is 3x squared minus 4x plus k being identical to the general quadratic equation ax squared plus bx plus c equals 0. Comparing the coefficients of x squared, we can see that a equals 3, and comparing the coefficients of b, we can see the coefficient of x, we can see that b equal -4. Comparing the constants on both sides, we can see that c equal to k. Then it says has no real solution. Has no real solution. The most feasible discriminant that responds to this requirement is this one. Has no real solution. B squared is less than 4ac. When a discriminant, a discriminant like this indicates that there's no real solution for the given function. Now we see that b is -4 less than 4. What is a? 3. What is c? K, which indicates that 16 is less than 12k, which indicates 12k is greater than 16. 12k is greater than 16, which indicates that k is greater than 16/12. Sorry. Is greater than 16/12, which implies is k is greater than 4 here, 3, 4, 4 here, 4, 4 here, 3 is greater than 4/3. Good. Then we'll consider another question. We come back. This is also another question, and this is a past question, past exam question. It says that the function g of s is equal to s squared plus 3px plus into bracket 14p minus 3, where p is an integer and has 2 equal roots. Find the first question, find the value of p, which carries 2 marks. And the second part, for this value of p, solve the equation. Well, this is not a big deal. In the first place, take your time to copy it because we need the space to start the analysis. So take your time to copy everything, and I'll be back with you in a minute. Take your time, copy it, pause the video and copy it. Okay, this is the given quadratic equation. We are told that it should have 2 equal roots. So the solution This is the given quadratic equation: x squared plus 3px plus 14p minus 3 should be identical to the general quadratic equation a squared plus bx plus c. Comparing the coefficients of x squared, we observe that a equal 1, b equal, comparing the coefficient of x, b equal 3p, and comparing the constants, we see that c equal 14p minus 3. For two equal roots, what does it say? For two equal roots, we use b squared, repeated root 4ac, which indicates that b squared is 3p squared equal 4 multiplied to 1 and then multiplied to c, which is 14p minus 3, which is 9p squared equal 14 times 4. 14 times 4 should be 56. 14 times, okay, we say 14 times 14p, we say 56p. 4 times 14p is 56p. 4 times minus 3 is minus 12. Very good. So it becomes like a quadratic equation in p, which is of the form 9p squared minus 56p plus 12 equals 0. Then we have enough space. Take your time to copy and we'll pick it up from here. Take your time, because we don't have all that much space. Take your time, copy it up to this point, then we pick it up. Okay, let's move on. We arrived at quadratic equation 9p squared minus 56p plus 12 equals 0. We are going to apply the completing square. 9, we factorize 9 outside. P square minus 56 over 9 p plus 12 over 9 equal 0. We can multiply, we can divide both sides by 9 to do away with this 9. So we have p squared minus 56 minus 56 over 9p plus 12 over 9 equals 0. Then we complete square. If we complete square, this one becomes p minus 56 over 2 times 9 square minus 56 over minus 2 times 9 square plus 12 over 9 equals 0. maybe we can continue from this side a bit. So we have P minus, these two should cancel this one to make it much simpler. 2 goes to 56, we say 28 over 9 square, which is this part, minus 56, the same 56, this one 2 will cancel it to make it, anyway, it is negative sign in the square root. It's not a big deal, we can still make it positive. So it is 56, 2 goes to 56, 28 square over 9 square plus 3 here, 4, 3 here, 3, 4 over 3 equals 0. Good. Then we have P square is P minus 28 over 9 square equal 4 over 3. Sorry. Equal 28 square over 9 square minus 4 over 3. We have put this one to the other side. Being negative here, it became positive there. We put that one to the other side. Being positive, it became negative over there. Then we can say that 28 square, we are crossing multiply. We are crossing multiplication. 28 square times 3 minus 9 square times 4. I mean, this one goes that way and multiply this one. So we have 28 square times 3. And this one goes that way, cross multiplication. Goes that way and multiply 4. And then over a common denominator being 9 square over 3, which is P minus 28 over 9 square. Okay. Do we have enough space? I think so. We are going to take square root on both sides. So we have P minus 28 over 9 equal plus or minus the square root, big one, 28 square minus times 3 minus 9 square times 4 all over 9 square times 3. Good. It's still a room. Oh, shall we continue from this side? Okay, let's go. Oh, take your time to copy it and we'll pick it up from there. Take your time to copy it because I'm going to clean this side and we'll pick it up from here and continue from this session. Take your time, copy it. Okay. Now, here we are. Picking from there, we have P minus 28 over 9. We are picking from here. Equal plus or minus this one, because it is square, we can bring it outside. So it becomes 1 over 9. The root of 28 square let's say square times 3 minus 9 squared times 4 all over 3. Good. We have P minus 28 over 9 equal plus or minus 1 over 9. If you use your calculator for this numerator, you have this one 2028 over 3, which is not different from P minus 28 over 9 equal plus or minus 1 over 9. If you use your calculator for this, the whole expression, you have times 26. So P becomes 28, we are pushing that one here, over 9 plus or minus 1 over 9, or we say 26 over 9. Over 9. Good. So we have P1 equal 28 plus, oh sorry, this is 26. Over 9. P1 equal 20 plus 26 all over 9. P1 equal 54 over 9. Then you have P2 equal 28 minus 26 over 9. P2 equal 2 over 9. This one, P1, 54 over 9 is equals to 6, right? So you have P1 equals 6, whilst P2 equal 2 over 9. P2 is inadmissible because we were told that P should be an integer. Therefore, P2, as P2 is inadmissible. As P must be an integer and it cannot be a fraction. Therefore, the solution is P1 equals to 6. Take your time to copy and then we'll pick it up from there. Take your time. Now let's continue. We came to conclusion that P is equals to 6, where P equal to 6, then this given quadratic equation becomes then we have g of x equal s squared plus 3, or is P is 6x plus 14, or this P 6 minus 3, which is not different from x squared plus 18x plus 84 minus 3. G of x equal x squared plus 18x plus 81. This is a quadratic equation in x. If you are factorizing this one, you can go by the completing square approach or by the normal quadratic factorization. By the normal quadratic factorization, you can see that the coefficient of x squared here is 1. If you pick up the coefficient and multiply it to the constant, then you can see that 1 times the constant, 1 times 81 is 81. 1 times 81 is equal 81. But 81 also equal, but 81 also equal 9 times 9. If we add 9 times, if we add 9 plus 9, what do we have? Though it is product, but if we add them, what do we have? We have 9 plus 9 is 18. Then we check this one to the coefficient of x, whether they are equal. 18, this is 18. Is 18 here? Oh yes, plus 18 is there. Therefore, the factor, the 9 plus 9 should be the factor of the quadratic equation. So we have g of x equal s squared. Instead of writing 18, we can say that 9x plus 9x plus 81. Then we factorize x outside. So we have x plus 9. This same factor should be here, x plus 9. Then if we multiply 9 plus 9 here, we can have this one, 9 multiplied to x, 9x. 9 multiplied to 9, 81. Then we have x, we factorize the common factor outside. We have 9 plus 8, plus x plus 9, x plus 9, which is not different from x plus 9 square. We say that therefore g of x, which is this one, s squared plus 18x plus 81 is identical to x plus 9. We have seen that this is a repeated factor. G of x is a repeated factor. And that should be the conclusion of the whole question. Though it was 2 marks, but it was, it was very strenuous to come to this point. It is a tough 2 marks question. The 2 mark, the question is little bit tedious. Then we'll catch up again in the next lesson, which will be 2-6. So in the meantime, have a wonderful time, and may the Lord Almighty God bless you, lift up his countenance upon you, and give you peace, make his face shine upon you, and give you peace. Shalom, shalom.